These are the solutions for the review for the final test, questions 64 through 80. So let's take a look at number 64 here, graphing linear systems of inequalities. And so here I've got a inequality that's in the slope-intercept form. So there's my y-intercept right here. So this is where I'm going to start. And so I'll go down 2 spaces on the y-axis, put the dot there, and then use the slope. Slope is 1 to 2, so that means you're going to go up 1 over 2 to the right. And the nice thing about the slope-intercept form is it gives us lots of points to be able to draw a nice line through. So before we get all excited and draw any type of line, look at the inequality. It does not have the line underneath. That means it does not equal. It's just y is greater than. So the values of y need to be bigger than the points that make up this line. So if I was to pick a point, like right here, the values of y have to be bigger. So that means I'm going to end up shading above this line. Looking at the next equation, I can either go ahead and solve for y, or I could use xy-intercepts. A lot of people like to solve for y, so we'll do that. So when you move the 3x to the other side, you end up having to do an opposite operation. So it makes it negative 3x, and then a plus 2. So when I divide by the 2, I end up with y is less than or equal to negative 3 halves x plus 1. So 2 divided by 2 made the 1. Negative 3 halves divided by 2 made the negative 3 halves. So we go ahead and graph that line, starting at positive 1, and then going down 3, 1, 2, 3 over 2. And that gives us some points to be able to draw the line through. And so I could also go the other way, up 1, 2, 3 over 2 to the left. So this line is a solid line. It's solid because it has the line underneath. And so that makes it solid. And so that means the points on the line are solutions. Now, which way do I shade? Well, look at the inequality. Y is less. Less means smaller. Now, why is it less? Because it points to the y. So whatever it points to is what I read. Y is less than or equal to this, so I'm shading below. Now I look to see where the arrows agree, and the only region in which they agree is right in here. And so that's where the solutions are. Looking at our next equation, start with the negative 3, that's my y-intercept, and then I go up 4 spaces, 1, 2, 3, 4, over 1 to the right. And I can do that again, and so I'll have some points to be able to draw. Now, this is another solid line because it has the line underneath the inequality sign right here. And so it's a positive y is less. Less means below. So the smaller y values are solutions from the line that we have. And so the next one's a good one for xy-intercepts. So I'm going to set that one up. 2x less than 6, and I also have negative 3y is less than 6. So when I solve, I get x is less than 3, dividing by the 2 there. And then over here, I get y is greater than negative 2. Why greater than? Well, because I divided by negative 3, and it switches that inequality sign. So let me go ahead and plot these points. 3 on the x-axis, negative 2 on the y-axis. I draw the line. It's a dashed line because the line is not underneath the inequality sign. It means the points are either greater or less. So here x has to be less. So x less means in this direction. Or I could read the y greater than negative 2. That means above. And so which region do they agree? Well, the only region they agree is right in here. Well, the next one has a y but no x. And so what this means is that the y-intercept is 2. And it means that all y values are 2. So it's going to be a dashed line going horizontal. Now, which way do we shade? Well, it says y is greater, so you're going to shade above that line. So the values of y need to be bigger than 2. Well, the next equation is a good one for xy-intercepts, but you end up with a fraction as the x-intercept. So I'm going to go ahead and solve for y. So I'm going to move that x term over. 2y is greater than or equal to negative 4x. Negative 4x plus the 2. Divide by 2, I've got now y is greater than or equal to negative 2x plus 1. Negative 2x because I divided 2 into the negative 4. So when I go ahead and graph this, I start up 1 space, and then just go down 2, right 1. Or I could go up 2, left 1, gets me on that same line. This line is going to be solid because it has the line underneath, and then from that point we can go ahead and graph or figure out the shading. So y is greater, which means above. So I'm going to end up shading above this line. Now look to see where those lines agree and the arrows agree, and the only region is up in here. Well, the next one has just an X, but before we get to that, let's start with this. So I'm going up 6 spaces. So it's all the way at the top of the graph, and then I'm going up 2 over 1, but I run out of room that way, so let's go the other way. Down to left 1 gets you on that same line. And then from that point, I can draw that line. It's a dash line going through all those points. And which way do I shade? Well, Y is less. Less means below, so I'm shading below that line. Moving on to the next one, just X, no Y. So this means you go over to 4, negative 4 on the X-axis, and it's a vertical line. That's the difference. So all X values are 4, but the X values have to be bigger than 4. So bigger than 4, bigger than the negative 4 means off to the right. So where do the values agree? Well, the only region they agree is this large region that we have in here. So where we shade are where the solutions are. Those points represent solutions. Let's take a look at our next type of problem, and it asks us to multiply binomials using FOIL. So the FOIL works this way. First terms make 12x squared. Outside terms make a negative 3xy. The inside terms make a positive 8xy. And the last terms, 2y negative y, multiply to make a negative 2y squared. So I'm able to combine the outside and the inside terms, these two right here, because they have the same variables raised to the same power. So I end up with this 12x squared plus 5xy and a minus 2y squared. That is my answer. Well, the next one, it's using FOIL again. First terms are x and x, making x squared. Then the outside terms, we got negative 4x. And I move to the inside right here, positive 2x. And then the last terms, that makes negative 8. And so I'm able to combine the outside and the inside terms. And so I'm left with an x squared minus 2x, because there's more negatives than positives. And then that minus 8. Well, in this one, 3x and x, those are my first terms. So that makes 12x squared. Outside terms make a negative 9x. Inside make a positive 8x. And the last terms make a negative 6. So I'm able to combine the outside and the inside terms again. So I now have this 12x squared minus an x, and then minus 6. And that is my answer. Over here we have another one with x's and y's. So let's do the first terms make 4x squared, and then the outside terms make a negative 12xy. Moving on to the inside, I'm going to write that as positive 2xy. Typically I write the variable that comes first in the alphabet, even though it's 2y times by the x. You can write it using the commutative property. And then negative 6y squared is what we get for the last terms. So again, you're able to combine the outside and the inside terms. And so your answer is 4x squared minus a 10xy and then minus 6y squared. People say, well, shouldn't I factor? Well, if you factor, you get right back to where you started. So let's not do that. We want it to multiply here. And then I do 2x times x for the last one here. So that makes 2x squared. Outside terms make a negative 12x. Inside make a negative 4x. And the last make a positive 24. So I'm able to combine those outside and inside terms to get this 2x squared minus 16x. Add because they're the same sign there, plus the 24. Looking at our next one here, this is a exponent rules. So just think of this as two separate problems. Reduce the fraction. Take out that common factor of 6. And so when you do that, you've got 2 and then 3. And then think about how many x's are left. You're taking 4 away from the top, 4 away from the bottom, leaves us with 6 x's on the bottom of the fraction. Same thing over here. Reduce the fraction first. Take out the common factor of 3. So you're left with 1 over 5. And then think about how many x's are left. Well, I'm taking away 15 from the top and bottom, so that leaves me with just 1 x on the bottom. So 1 over 5x. Over here, common factor of 2. So I take out that 2. I got 3 over 4. This time the x's are on top, because I take away 3 from the bottom. 3 from the top leaves me with 6 x's on top. Over here, do the same thing. Take out the common factor of 6. So do that division. I've got 12 over 1. The 1x cancels out one of the x's on top, so I'm left with 2x to the third over 1, or just 2x to the third power. Over here, common factor is 6, and so I take out that 6, I've got 4 over 3, and then I take out the x's that are in common, so I have 10 x's left on the bottom of the fraction. Looking at the last type of problems that we're dealing with here, these are adding polynomials. So when I add, all I'm doing is just rewriting, collecting like terms pretty much. I like to write the terms that are the same underneath the values that I'm going to collect them with so that I can see the problem a little bit easier here. So I'm adding, and when I add, I just count up how many x squareds I have, which would be 9x squared. When they're opposite sign, I got to subtract though, so this makes a positive 5x. And then over here, when they're the same sign, I end up adding, so negative 7. That would be my answer. Well, the difference is when I subtract, I want to add the opposite. So I'm going to change it to addition, and all of these signs are going to switch. And so this becomes a negative 4, positive 2x, negative 8x squared. Then I just rewrite them underneath the ones I combine them with. So negative 8x squared. I'll squeeze in this positive 2x here, and then the negative 4. And so I just collect, and if they're opposite signs, I subtract, same sign I add, so negative 3x squared, and then I have a positive 2x, and then here they're the same sign, so it makes a negative 10. That is the answer. Over here it talks about the perimeter of a triangle is this. So this is the whole perimeter. That's like a sum. It's adding up all the sides. The sum of two of the sides is this. Find the third side. Well, if this is the total right here, what I'm going to end up doing is set up a subtraction problem. 3x squared minus 2x plus 8. And I'm going to take away the other two sides, which sum to x squared plus x minus 4. And so when it's a subtraction problem, remember, you're going to add the opposite. So change it to addition, change all of these signs to their opposite. And then from that point, you can collect. So I'll collect put the negative x squared here, put the negative x here, and the positive 4 here. Add this stuff up, you got 2x squared minus a 3x plus a 12. That would be our answer. Well, those are problems up through 80. Check other parts for other problems.